So question 15C. A large wooden turntable in the shape of a flat uniform disc has a radius of 2 meters and a total mass of 120 kg. So I visualize it. So we have a turntable. The shape is uniform disc. Whereby the radius is 2 meters and the mass is 120 kg. Okay, so from the statement given, uniform disc, you can find the moment of inertia for the disc lah. I give you the hints lah. So you find from your lecture note what is the formula to calculate moment inertia for uniform disc. Okay, so sambung cerita. The turntable is initially rotating at 3 radians per second about a vertical axis through its center. So this turntable is rotate through a vertical axis at its center with the initial angular velocity 3 radians per second. Okay, so this is the initial situation. This is our initial situations. Okay, so suddenly a 70 kg parachutist make a soft landing on the turntable at the point near the outer edge. So we visualize the situations. I redraw the turntable. So this is the turntable rotating about the axis at its center. So what happened to the question? Suddenly a 70 kg parachutist make a soft landing on the turntable at the point near the outer edge. Okay, so a parachutist landing at the outer edge. Okay, the parachutist landing at the outer edge. So how far is the parachutist from the axis of rotations? It will be 2 meters lah. Why? Because the radius of the disc is 2 meters, right? So find the angular speed of the turntable after the parachutist land. Okay, assume that you can treat the parachutist as particle. So we assume the parachutist as particle. So we want to find the angular speed omega after the parachutist land. So after the parachutist landing on the outer edge, that one kita consider sebagai final. Okay, final. So konsep apa kita nak apply kat sini? So we understood that, what we understood? We know that when parachutists land, landing on the turntable, what happened? The mass of the system for sure will be increased. So if our mass of the system increase, that means that our moment inertia of the system now will also change, increase, went up, whereby the moment of the inertia of the system now will be the moment of inertia for the parachutist plus with the moment of inertia for the turntable lah. The turntable is a disc. Okay? Okay. So if we refer to conservation of angular momentum, angular momentum, our angular momentum is always constant. So in other words, when we have a change in moment inertia, means that there will be a change in angular speed. Okay, so how we are going to find the angular speed of the turntable after the parachutist land? So we are going to apply conservation of angular momentum. Total angular momentum initial will equal to total angular momentum final. Okay, so initial we have I this and the speed is 3. So we are going to have I of the disc multiplied with initial angular speed. Final we have the I for the parachutist plus with the I for the disc, and then we have the final angular speed omega lah. So class, I'll leave the solution for you to solve it by yourself. Try to solve it. Think of what the equations for moment inertia of the disc and also the parachutist if we assume the parachutist as particle. So snap your solutions and then submit using Google Classroom.